Okay, this will be the problem trail for the first half of Chapter 3 test in pre-calc. The problems, I'm actually going to do them in kind of backwards order. That's just how they, when I opened them on my computer, they were left open. So we'll start with number 10, find the exponential equation that goes through and they give you 2 points. So there's a couple ways to do this. Basically, when they give you points, you know, again, if we're thinking exponential, we know it's going to be y equals a times b to the x. And when they give you points, like I said, the initial value, what you start with is always the one that goes with when x is 0. So that 3.5 is going to be your a value, and the other point is going to be your x and y. So you can just go ahead and plug things in if you want into the general form here and do some algebra. 3.5 times b. So b is the thing we don't know. I don't know what the growth factor is to the 4th power. And you could actually divide both sides by 3.5. And then you would get some number. I don't have the calculation because I actually did this a different way, but if you were to divide both sides by 3.5, and then again you get some number, so whatever that number is going to equal b to the 4th power. And to solve for b, then you could just simply raise both sides to the 1/4 power. Okay, and you'll notice that again, this will just be some number. Make sure parentheses are on your 1/4, and then that'll just be a b now, right? Because b to the 4th to the 1/4 becomes b to the 1st, and then you'll know your b value. And we already knew our a from the beginning, so putting those two things in the correct spots here would give us the equation. The way I actually did it was with the, using the calculator and the regression. So I'll show you that real quick. That might be helpful on the test. When they give you 2 points, so 0, 3.5, anytime you have some points here, so if you're on your home screen, excuse me, and you want to enter data and you want to do regression, go into stat and just enter those points into the lists here. So I'm going to clear the old stuff from the previous problem. Okay, so again, I know my values were for x's. X is going to L1, 0. The other x was 4. And the y's that went with them were 3.5. And I think it was 14 point, what was it, 14 point, or I'm sorry, 13.14. And then for exponential regression, we only need 2 points. So I can go right now and go back to the stat screen over to calculate. This is when we get all of our models, all of our regression models. And I want to do an exponential regression. Okay, and just make sure your x list was L1, your y list was L2. I don't really need to store the equation. If I did, this is where I could put y1. But I just want to calculate and get the equation. Excuse me, and it's doing a similar thing. It's finding the a and the b for us. Okay, again, and notice we knew the a was 3.5 from given, and then the b value should have been the same thing as if you would have done it algebraically. When you raise that number to the 1/4, we would have got the same 1.39. Okay, so that would be our equation. Now, just a quick piece of advice: if this had been a logistic equation, right? Because right now it's just kind of like, 3.5 times something. So it's just kind of growing like this. So you only needed 2 points. We had a point here and a point here. But if you know it's logistic and it kind of ends out, that's when you would need a 3rd point out there, so you would be able to let the calculator know when it's ending up. But for exponential, only need 2. Okay, so there's our equation there. Okay, so let's keep moving forward. So the answer to that one was B. Okay, so that one's good. Oh no. Let's go back to number 9. Solve for x. Okay, and we have this equation here. So again, it's an exponential equation. It's an a b, there's an exponent equals something. So a little bit of confusion I've seen throughout the day. We need to divide that 2. Just get rid of that right away. So divide both sides by 2 immediately. 2 is not part of the base. Okay, the base is 12. So that 2 gets divided. You'll have 12 to the negative 3x, and then 21 over 2. In this case, it's okay to go decimal because it's a nice terminating decimal. And then once we have it in this form, now it's straight up ready to be changed to log form. Okay, because again, notice we're trying to solve for an exponent. So let me pick it up here. Let's switch forms on it. Okay, it's log, and again, I know the base is 12. and I'm taking the log of 10.5, and logs always equal exponents, so the exponent's negative 3x. Okay, so what we could do then is do, do this part on a calculator, and that'll just be some number. Okay, so let's do that, log base 12 of 10.5. Okay, so the new way, just get rid of that ink there. If you have the newer calculators, remember we can do the alpha window, and it can do log base for us. Otherwise, you're going to have to do the division problem. Um, so in this case, it's log 12 of 10.5, and on the old system, you'd have to do log of 10.5 divided by log 12, and that it should get you the same thing. Okay, so that's the logarithm part of our issue of our question. Um, so that number that was there actually equals negative 3x. Okay, so this was like 0.92, whatever it was. To get our final answer, to get x, you just simply have to divide both sides by negative 3. Okay, so that becomes the final step in this problem. We're just going to go ahead and have that answer in there. We're going to divide by negative 3, and that is going to give us our answer of negative 0.315. Okay, so negative 0.315. So let's hope that's up there. Yep, looks like D for number 9. Okay. All right, let's get rid of that one. Oops, I'm going to keep closing that one. I probably should just be going here. Okay, number 8. Find the domain and range of that function. So I'm going to kind of do this one without the calculator. You're free to graph it in the calculator if you want to. But again, it's 0.5 to the x. Okay, so the base is 0.5. So it's going to be decay because that's less than 1. And then there's a plus 2 on there. Okay, so if you remember your normal or your regular old exponential decay, the parent function, like if that plus 2 wasn't there, it would kind of come along here and actually hit the, oops, it actually would go up this way too, and it would just approach 0. But since we have that plus 2 sitting there, vertical shift, right, that's going to shift everything up 2. So what it's going to do is actually just kind of move that whole thing up a little bit. So the graph is actually just going to do this kind of thing now, and it's going to basically approach 2. Okay, so that's important for our range, right? That's a horizontal asymptote there. That's usually at 0. That's now up at 2. So the domain for these is all real numbers, okay? Because you can put in any number you want for x. But the range now is going to be, instead of 0 to infinity, it's going to be 2. And we're never going to quite get down to 2, so I'm going to use parentheses. And then I think for the answer options, though, the all real numbers could just be written as this way. So negative infinity to infinity. Okay, so number 8, the answer there should have been D. Okay, so let's make sure negative infinity to infinity, and then 2 to infinity. Uh-oh. This answer is B, sorry. I just said the wrong letter. The answer is B there, right? Okay. All right. Let's clear that, and let's move along. Too many windows open here. I'm all over the place. I want to close that one. Let's go to problem 7. Okay, another solve for x. So again, we want to get this solved. The thing we need is part of an exponent. So we're going to go to log form. Okay, that's what logs do. They help us find exponents, right? So it's going to be log. Again, I always do it in this order. I say, what's the base? Okay, the base is 3. Okay, the thing I'm taking the log of is the 127th. And I know that because the logarithm always equals whatever the exponent is. Okay, so log, the base was 3. It needs to equal 2x, so the 127th needs to be the thing we're taking the log of. Okay, and you can actually do this in your calculator and do this left side of the equation just like we did in the previous problem where we would just do a change of base formula. Okay, so again, this is just log base 3 of 127. It's going to be some number. That number equals 2x. So we will just take that number and divide it by 2. And that'll give us our answer. Okay, so why don't we do that real quick. Log base 3 of 127th. Okay, so again, I'm going to do the alpha window log base 3, okay, of 127th. Okay, and again, that equals, that's what equals 2x, right? So if we just take that and divide by 2, we will get our answer there of negative 1.5 or negative 3 halves. That's probably how it was written on the sheet. So negative 3 halves down there. Yep, so the answer was D for that one. Okay. And let me just mention on this one, you could have done it a little differently if you wanted to. If you noticed that you could write both of these with the same base if you wanted to. If you recognize 1 over 27 is really 1 over 3 to the third, right? Which is really 3 to the negative third. And then that would allow you to do that little shortcut method where now you can just set the bases equal to each other. And notice you'll get the same answer when you divide by 2 both times. Okay, like negative 3 halves. So kind of some different options. The log process will always work, but if you notice the other way works, where you write equal bases, it's sometimes a little quicker. Okay, so that was number 7, I believe. So we can move to number 6. Okay, another one. We got to solve for x, another equation. So this one again, it's something times e to some power. So I want to get rid of that 3 out front first. I'm going to divide both sides by 3. Okay, always get rid of the a values anytime you're doing this. Even later in the chapter, we'll do some more word problem kind of things. You always want to divide that a out. And now this one, I would leave the 13 over 3 as 13 over 3. Okay, I don't really want to change it to a decimal because that decimal goes on forever and there'll be rounding and it won't look good. So if we do this, we're now ready to change to log form, because again, your variable is an exponent. So if we change to log form, I'm going to write this out. Log, what's the base? Okay, the base is e. Okay, I'm taking the log of 13 over 3, and I know it needs to equal whatever the exponent was, right? Okay, and that might look weird. I wrote log base e, but just recognize that's just the natural log. So this is really just the natural log of 13 over 3. Okay, again, that's all base e means. It's just the natural log, and your calculator has a button for that. So all we need to do really is take the natural log of 13 over 3 on your calculator, and then that will equal negative 1 plus x. So if we just add the 1 to both sides, so the natural log of 13 over 3, whatever that is, some decimal on your calculator, add 1 to it, that should give you your x. Okay, so let's go ahead and do that. Okay, again, natural log 13 over 3. Okay, you can either close it up, press equals, or I could have just thrown the plus 1 after the parenthesis there, but I'll just do separate steps here. So we should be looking at about 2.47-ish. Okay, and I believe we rounded to 2.47 in the options there. So let's take a look, 2.47, yep, so C for that question. Okay, oops, line that up so you can get one more look at it. There we go. Okay, and now moving to number 5. Excuse me, there were 10 members of the fashion club when it started. The following year, there were 20 members. Okay, assuming the pattern continues, when will it have over 100? Okay, so this one, I probably should have been a little more clear, because when I say the pattern continues, you know, you could say, is the pattern, I see we're going from 10 to 20, are we just adding 10, or are we doubling? So I'll be a little more specific, but in this chapter, we're dealing more with exponentials, obviously, not linear growth, so it's not going to grow by 10 each time, it's going to actually get multiplied by something. So what I would do is kind of think of a little table. When you first started, there were 10 people. 1 year goes by, that doubles. Another year goes by, the 20 now doubles. So it's not just adding 10, it's actually getting multiplied by something. Okay, and 30 and so on. So somewhere, you know, in between 3 and 4, we're basically saying, when is it going to be 100? You know, so that we're trying to find that x value there. So I think the best way is to actually write yourself an equation. Okay, and that equation, okay, again, could be y equals starting value, right? So we started with 10. And then just think about what's the b, what's the growth factor? It's getting times by 2 each year. Okay, and in this specific problem, they want us to find what x value makes the y be 100. Okay, so if I put 100 in there and see if we can solve that equation for x, then we'll be in business. Okay, so again, we're going to divide both sides by 10. There's an a value there, right? So let's divide both sides by 10. So 10 is going to equal 2 to the x. And we can go ahead and change the log form again. So pretty much every problem, if the variable is an exponent, you're going to change the log form. Log, I know the base is 2 of 10 equals the exponent. So this is something that you can just do straight into your calculator. Log base 2 of 10, and that'll give us our answer. So again, it's either log 10 divided by log 2, okay? Or the new system again, you can go ahead and enter it just like it looks, right? Log base 2 of 10. And that should give us our answer, about 3.3 years. So again, we knew it was between 3 and 4, but that gets us a little more accuracy, and that's what we like. So 3.32 for that one. Okay, so B for this problem. Okay, so we're done with number 5. Time to go to number 4. The value of your car is currently $10,000. This value is decreasing at a given rate. How much will it be worth in 7 years? Okay, so a lot of information. So I think we're clear on the A value being 10,000, right? So the value Y will be 10,000 times something to the X. X is going to be the number of years, so we're going to do specifically for 7 in a second. But let's just set up the general equation. And this one I saw a lot of questions with too. Do I use this directly and make that be the B value? And the issue here is if we did, like let's just say, point or 3.5%, I mean, that's the decimal for it, right? So think about what happens if you take 10,000 and you times it by 0.035. Okay, you're going to get a pretty small number. You're only going to get 3% of 10,000. But that's not exactly what we're doing here. The 3.5% is how much you're losing of the value. Okay, so basically, if you think about it, let's say you start out with 100% of something, and if you take away 3.5%, you're still left with quite a bit. You still have 96.5% of what you had before. Okay, and the Y value needs to be what is the new value of this car X years after we start. Okay, so I don't want to know 3.5%. That's how much is getting subtracted each time. So if you're going to use the 0.035, you're going to have to do a subtraction problem. It's going to get complicated. I'd rather do the subtraction problem from the beginning up here and know that my growth factor, or it's decay actually in this case, the decay factor is 96.5%. Okay, which of course after moving the decimal is 0.965. Now see if that seems a little more reasonable. 0.965, the number's only getting smaller a little bit, right? Because 0.965 is only a little bit less than 1. And that should seem to be in line with losing 3.5%. And if that happens every single year for 7 years, we can put our 7 right in for X there. And now the Y value will just be how much it's currently worth. It won't be how much has it lost. That will already be like accounted for basically. Okay, so we just need to simply go into the calculator and do 10,000 times 0.965 to the 7th power. Okay, so if we do that, let's give some room here, 10,000 times, again, 0.965 to the 7th power. And that should give us our final answer of around $7,700. Okay, and again, remember that came from 100% minus the 3.5%. Okay, or 1 minus the 0.035 as in decimal form. That's where the 0.965 comes from. Okay, now let me just say this. If it was growing by 3.5%, okay, if it was growing, you would just have to do 1 plus that 0.035, and that would give you a B value of 1.035, and that would then make each value be 3.5% larger than the one before. Okay, so just kind of watch out if it's growth or decay. It could either be 1 plus or 1 minus that rate. Okay, so that was that one. So number 4 was D, right? I think that's what we got. Okay. What else we got? Problem 3, convert into log form. Oh, good, a quick one. So this one we're just wants us to convert it, just rewrite it, right? So take it's right now it's written as an exponent. It's written as 5 to the second, or to the negative second equals 1 over 25. So log form would be log, okay, what's the base? Here's my base. Okay, I know that it equals the exponent, so the negative 2 is on the other side. So the 1/25th is the thing we're taking the log of, and it equals the exponent. Okay, so just be careful too when you're reading this out. It's log base 5 of 1/25th. It's not log 5 to the 1/25th power. The base is like a subscript down there. We're taking the log of 1/25th. Okay, with a base of 5. Okay. All right, number 2, half-life problem. Okay, good. So this one's a little bit tricky until you see it, I think. So the half-life's 3 hours, right? So if you think about, I want to get a little more space in right here. So let's say the half-life is 3 hours. So every 3 hours, half of the amount of the substance is decaying or dying off. Okay, so 3 hours, 6 hours, 9 hours, 12 hours. And this one they happen to tell you you're starting out with 300 grams. So you don't have to use 100% if they actually give you like an amount. Okay, so we get halfway down, we get down to 150 grams at 3 hours. Okay, then half of 150 is 75. So that's where we're at 6 hours. Okay, half of 75, okay, would be at 9 hours and so on. So you can kind of see it's actually decaying exponentially. So it's just going to keep getting closer and closer. We're going to get that asymptote down at 0. So it's technically never going to get to 0, you know, in this model at least. Okay, so my question was, how much will remain at 10 hours? So right now these are just hours, right? Okay, so at 10 hours, I want to be able to ask myself, you know, how much would remain then? Okay, so here's the issue. I think we need to get this in everything on the same page because we cannot just do, we know we're starting with 300, right? We know the half-life, so it's getting multiplied by 5. I can't just throw a 3 up there, okay? Or I can't just throw a 10 up there because what needs to happen is the x value needs to be the number of half-lives that happen. Okay, because each half-life is when the value gets cut in half. So if we set up a scale down here, the number of half-lives, again, each half-life is 3 hours, right? So that's 1 half-life. 6 was 2 half-lives. 9 was 3 half-lives, right? 12 was 4 half-lives, again, because each one is 3 hours. So that's what the exponent needs to represent. So my question is, what would go in correspondence with 10? So the easiest way to do that is just, I mean, you can notice a pattern too, hopefully. If you notice, isn't it always just the number of hours divided by 3? That'll give you what a half-life, or how many half-lives I should say. 12 hours was really 4 half-lives. So 10 hours is really 10 over 3 half-lives. Okay, so it was like 3 1/3 half-lives. So if you use that for your exponent, that's going to work out on this problem. So it's going to be our starting value, always times half for a half-life, and in this case it's going to be 10/3. Just leave that again as a fraction. I don't want to go decimal because that involves rounding, and that isn't going to be super accurate. So I think all we need to do is y is going to give us the amount remaining is always what you started with times half to the 10 over 3 power, and again parentheses depending on what type of calculator software you have. So let's go ahead and throw that in and get an answer here. 300 times 0.5 to the 10 over 3. Okay, and I don't need parentheses on this one because I can I can see that the division problem is all up in the exponent, but you may, and it might just be safe to throw them around there. And that'll give us an amount remaining. Okay, so about 29.8 grams would be left. Okay, so that one looks like C. Okay, so C for that one. Okay, and finally, getting to number 1. Just going back to some stuff we did, excuse me, real early in the year with the transformations and everything. If they're saying this is kind of like your parent function, um, and I can see there's a couple differences here. I got a +1 up there and then a +2 in there. Just kind of remember anytime there's a plus or minus at the very end, this is going to be like a vertical shift. You're just really adding 2 to the y value, so they're all just going up. And then something happening inside the function, okay, with the x, okay, and in this case, inside the exponent, that's going to be a horizontal shift. Um, and remember, the horizontal ones are kind of backwards from what you would think, so this +1 is actually going to be a left one. And then the +2 on the end is straight up, it's an up 2. So the issue is, what order do we do these in? And if you think about order of operations, something inside an exponent is going to have more priority than just throwing a +2 on the end. So it would actually have to be done in this order, the horizontal shift first, and then the vertical shift of up 2. Okay, so it looks like A should be the answer for that one. Okay, now when you actually graph it, in this case it probably wouldn't matter which one you actually did first. But if there were reflections and stretches and stuff, then you'd want to make sure to do it in the right order. Okay, so A for that one. All right, so that was the problem trail. Hopefully that helped clear some of this up.